Now, I would like to discuss to you another method which is very important method to find the solution of differential equation and a unique technique. This method is known as method of variation of parameter. Uh, what is this method? In this method, how to pursue the solution for the complementary function. Our solution is as we use the complementary function by using the ordinary method as we have used for the pursue the solution of ordinary higher order differential equation, but that can be expressed as C1 y1 plus C2 y2. So we will write our complementary function as C1 y1 plus C2 y2. It means that what we will obtain the value of y1 and y2 from the complementary function, and so that we will use this y1 and y2 to pursue the solution of particular integral, that is u times of y1 plus v times of y2. And what is the formula for finding the value of u? That is integral of minus y2 g of x upon y1 y2 prime minus y1 prime y2 dx. Similarly, for formula for finding the value of v is y1 gx into dx divided by y1 y2 prime minus y1 prime y2. This factor which is given into the denominator is also known as Roskian of the function. So let's see how we can find the solution of the differential equation by using this technique. So our first problem is y double prime minus 4y prime plus 4y is equal to 1 plus x into exponential 2x. So we will find the solution of this differential equation by using method of variation of parameter. In the method, first of all, we will find the complementary solution by taking the auxiliary equation of the differential equation. So the auxiliary equation of the left hand side becomes m square minus 4m plus 4 is equal to 0. So values of m is equal to 2 and 2. These are the repeated roots. So the complementary solution becomes c1 c2x exponential 2x, and by multiply this exponential 2x by both terms, so this can be written as y is equal to c1 exponential 2x plus c2x times exponential 2x. The term which is present with c1 is y1 and c2 is y2. So here we will consider y1 and y2 from these two terms. So the value of y1 and y2 are y1 is equal to c exponential 2x and y2 is equal to x exponential 2x. So these are the values of y1 and y2. Now, how to pursue the particular integral? For the particular integral, we use the formula, that is yp is equal to u y1 plus v y2, and the value of u would be minus times of y2 g of x dx divided by y1 y2 prime minus y1 prime y2. So we, with y1 and y2, we must need their derivative for the substitution. So first we are going to find the value of u, that is uh, minus times of y2 into g of x, that is 1 plus x exponential 2x dx whole divided by y1 derivative of y2 minus this is y1 prime derivative of y1 and this is y2. Now after multiplication taking common exponential 4x, so the rest of term will be cancelled out, that is only one remaining into the bracket. So and what happened here, this e raised to the power 4x in the denominator and e raised to the power 4 is in the numerator. So basis same, power will be combined, that is 4x minus 4x. So exponent power 0, that will be 1. So now only minus x square dx will remain, and the integral of x will be the x square upon 2 and integral of x square will be the x cube upon 3. Now we'll find the value of v according to the formula. V is equal to y1 g of x dx, and Roskian, that is in the denominator, was exponential 4x. Directly we are substituting the value as we have already calculated when we are going to find the value of u. Uh, so that is exponential 4. So again We will apply the same formula, basis same, power combined, so that exponential power 4x will be cancelled out. So the remaining term will be 1 plus x dx, and the integral of 1 plus x dx becomes x plus x square upon 2. Now the particular solution yp becomes minus x square upon 2 minus x2 upon 3 into exponential 2x plus x square upon 2 into x exponential 2x, and after simplification it can be written as 1 upon 2 x square plus x cube upon 6 into exponential 2x. This is the value of yp, and we obtain this value from which equation? From the equation yp is equal to u1 y1 u2 u2 y2. So this is u1 y1 u2 y2. So our yp is 1 upon 2 x square plus x cube upon 6 into exponential 2x. Now general solution we are writing here, which is y is equal to yc plus yp. It is combination of complementary particular solution, that is c1 exponential 2x plus c2 x exponential 2x plus 1 upon 2 x square plus 1 upon 6 x cube into exponential 2x. Here I am explaining you this factor, which is y1 y2 prime minus y1 prime y2 is equal to in determinant of y1 y2 y1 prime y2 prime. It is known as Wronskian of y1 y2. Is how to spell is Wronskian, Wronskian, and expressed by the capital W. So this is the formula. For instance, uh, formula for u and v, we can write it as u is equal to minus y2 g of x divided by w, and v is equal to y1 g of x divided by w. We can also use into d of x also. So these are the formulae for finding the value of u and v. So now we are taking another problem, that is d2y upon dx square minus y is equal to 2 upon 1 plus exponential x. First of all, we are going to find the complementary function from this equation, that is auxiliary equation of differential equation becomes m square minus 1 is equal to 0, m square is equal to 1, so m is equal to plus minus 1. So yc is equal to c1 exponential x plus c2 exponential minus x, so that we obtain the value of y1 is equal to this is y1 and this is y2. Y1 is equal to exponential x and y2 is equal to exponential minus x. And also we are going to find the derivative. So the y1 prime becomes exponential x and y2 prime minus times of exponential minus x. Why we have taken the differential? Because we need their derivatives in the Roskian in the denominator of the integral. So we know that what is the particular integral formula? Yp is equal to u y1 plus v y2, and what is the formula for u? U is equal to integral of minus y2 g of x dx divided by w, that is minus value of y2 into g of x is 2 upon 1 plus x dx, and whole divided by w, and w is what? W we can obtain from the y1 y2 prime into y2 y1 prime y2. So that is exponential x minus exponential x into minus exponential minus x. So the value of w would be minus into minus, that is minus 2, and this is so that minus 2 exponential minus x divided by 1 plus x, and here basis same, power combined, so e power x minus x plus x would be e power 0, and here also x power x minus x would be 0. So only minus 1 and minus 1, that is minus 2. And this term, this minus 2 and this minus 2 will be cancelled out. Only the remaining term will be exponential minus x divided by 1 plus x. So this term, which is the remaining term after cancellation of minus 2 to remaining term is exponential minus x divided by 1 plus x into dx. Now we can shift exponential minus x into the denominator, because we have negative power. When this will be shifted into the denominator from the numerator, this power will be positive. Now we have two factor. um, Breaking the LCM, this factor can be written as 1 upon x minus 1 upon 1 plus x. By breaking the LCM, this entire term can be written as in this form. Why we break the LCM? Because we want to get the integral, so that um, for obtaining the solution in the easy way, we break the LCM of these two terms. Or you can find the factor by using the integration by partial fraction. By the partial fraction, you can also obtain this two factors. So again, shift exponential x, that would be exponential minus x dx minus exponential minus x dx upon exponential minus x plus 1. This is the formula, which is sorry, we can integrate directly exponential x. The integral of exponential x is exponential must be present negative sign here, because the derivative of exponential minus x would be minus 1. Similarly, when we have function in denominator and derivative in numerator, so the integral of 1 upon x becomes ln x. So this is x and this is 1. So this, the integral of this entire term will be ln e power x plus 1. Similarly, we'll find the value of v, that is y1 g times of w into dx. So this is the value of y1, value of g, and value of w is minus 2. Again, these two will be cancelled out. The remaining term will be exponential x divided by 1 plus x. And here you can see that 1 plus x have the derivative in numerator. So when we have function in denominator and derivative in numerator, so integral can be directly obtained by using the log of the function. This is the function and this is the derivative. So the integral would be ln of 1 plus x. This is the derivative of integral of the function. Now, yp can be written as minus exponential minus x plus ln e minus x plus 1 into, that is क्या, u v minus v sorry, u y1 minus v y2. When we substitute their values and multiply and simplify them, first term, this exponential x will multiply with two terms, so that exponential x into exponential minus x would be e power minus x plus x, and this term will multiply by this term, that would be exponential x ln of exponential minus x plus 1 minus this exponential x with negative sign with multiply by the log of this term, so that this would be exponent power 0, it is minus 1 plus this two term will remain same. So the general solution can be written as y is equal to c1 exponential x plus c2 exponential minus x minus 1 plus exponential x ln exponential minus x plus 1 minus ln 1 plus x whole divided by x. So this is the solution of this differential equation. I would like to share another very important method to you to pursue the solution of differential equation. This method is known as method of undetermined coefficient. This method is very important and uh, easy method to find the solution of higher order or ordinary differential equation. As earlier we have discussed method of variation of parameter, now we are going to discuss method of undetermined coefficient. In this method, we obtain such a kind of solution of such a kind of differential equation having a constant coefficient, that is a d2y upon dx square plus b dy upon dx plus cy is equal to g of x. You can say that the similar kind of equation is this we have uh, solved earlier, and complementary function can be obtained by using the similar manners, and we have used earlier this method used to get the particular integral of the differential equation. And according to the method, which kind of assumption we use here for particular integral based on the assumption according to the given function g of x. If g of x is a exponential bx, so we assume yp is equal to a exponential bx. If g of x is a sin bx uh, or a cos bx, so we'll consider a cos bx, a sin bx. If the function is a polynomial, something like a naught xn plus a1 xn minus 1 and so on, so yp becomes a naught xn plus similar kind of polynomial with unknown coefficients. That is why, because all the times we are using unknown coefficients here to find the particular integral, so that is why this method is known as method of undetermined coefficient. Now uh, we are going to solve a problem. The problem is we have taken, that is a second order differential equation, d2y upon dx square minus 2 dy upon dx minus 3y is equal to 36 exponent power 5x. So first of all, you know that how to find the complementary function of the differential equation. So I am not going to discuss. Okay, first I would like to discuss from the complementary. So how to pursue the complementary function from this equation? Taking m square auxiliary equation, m square minus 3m minus 2m minus 3 is equal to 0, and the factors are 3 and minus 1. So complementary function becomes y is equal to c1 exponential 3x plus c2 exponential minus x. Now here, look at this. What would be the particular integral for this one, yp? Because at the right hand side we have this kind of function a exponential bx. So gx is a exponential bx. It means 36 exponential 5x. So we will consider here the value of yp would be yp is equal to a exponential 5x, right? So for instance, we will substitute uh, the value of y in the entire term. So here we have second order derivative. So when we substitute the value of y, we must be differentiate this two times. And here we substitute the value of y, we must be differentiate this one time, minus 3 value of y is equal to 36 exponential 5x. The first derivative would be a is the constant term, it is the coefficient, and the derivative of exponential 5x would be 5 exponential 5x. So this will be 5a exponential 5x minus 5a exponential 5x, derivative of this term, and 3a exponential 5x is equal to 36, remains same. And now one more time we will differentiate. So again we will get 5 times of exponential 5x, that will be 25 a exponential 5x minus 10a exponential 5x minus 3 exponential 5 is equal to 36 5a. Taking common exponential 5a and will be cancelled out from the entire term, so that remaining term will be what? So exponential 5x is common. Remaining terms 25a minus 10a plus minus 3a is equal to 36 exponential 5x, and that is 12a is equal to 36 exponential 5x divided by 5x. This 2 will be cancelled out, or basis same power combined, that would be exponential 0, that is 1. So 12 3 36. So the value of a here is 3. So a is equal to 3, so that yp becomes 3 exponential 5x. Now the general solution of differential equation becomes y is equal to c1 exponential 3x plus c2 exponential minus x plus 3 exponential 5x. So you can see that this solution is more comfortable and more easy way to find the solution of differential equation by using this method. So we are going to discuss another problem by using the same method. Here we have the differential equation y double prime minus 2y minus 3y is equal to 14 cos 2x. So left hand side, uh, here we have trigonometric terms, so that we will consider here y is equal to a cos 2x. So because we need y prime and y double prime, so that we will find the value of y prime and y double prime, that would be y prime will be minus 2a sine 2x, and y double prime will be minus 4a cos 2x. So I'll substitute all the values in equation number 1. So equation number 1 becomes 4a sine 2x minus 7a cos 2x is equal to 0 times x sine 2x, 14 cos 2x. So equating the coefficients of sine and cos from both sides, so that we get 4a is equal to 0, a is equal to 0, and minus 7a is equal to 14, a is equal to minus 2. Is it possible we can get the two different values from a similar equation? So this is not possible. So that what we have to do for further solution, we will change our choices, because first we choose the value for value of y, that is y is equal to a cos 2x. Now we will choose both the values for obtaining the value of yb, that is now we will consider y is equal to a cos 2x plus b sin 2x for balancing the equation, because from this equation our solution was not consistent solution. Now y prime would be minus 2a sin 2x plus 2b cos 2x. Similarly, again differentiate, y double prime becomes minus 4a cos 2x minus 4b sin 2x. Now substitute these three values in equation number 1 in the question, so that we obtain minus 4a cos 2x minus 4b sin 2x minus 2 times of minus 2a sin 2x 2b cos 2x minus minus 3a cos 2x minus 3b is equal to 14 cos 2x. So here minus 4a cos 2x minus 4b sin 2x plus 4a sin 2x minus 4b cos 2x minus 3a cos 2x minus 3b sin 2x is equal to 14 cos 2x. Now equating the terms having the similar coefficients, uh, it can be written as minus 4a cos 2x minus 4b cos 2x minus 3a cos 2x. So those terms consist of cos we are writing together and consist of b writing together. So here in these three terms taking common cos 2x, the remaining term would be minus 4a minus 4b minus 3a. And from these three terms we taking common sin 2x, remaining term would be 4a minus 3b and minus 4b. These are remaining is equal to 14 cos b. Now we can equate the coefficient of sine and cos from the left and right side. When we will equate the coefficient of cos is here minus 7a minus 4b and here is 14. So first equation becomes minus 7a plus 4b minus 4b is equal to 14. So that a is equal to 14 plus 4b upon minus 7. Similarly, from second equation, here coefficient of sine is 4a minus 7b, but here we don't have sine, so that coefficient of sine will be 0. Therefore, second equation will be 4a minus 7b is equal to 0. From this equation, a becomes 7b upon 4. So the value of b we can substitute in equation number 1, or we can compare these two equations. By comparing these two equations, 7b upon 4 is equal to 14 plus 4b upon minus 7. By the cross multiplication and simplification, that will be minus 49b minus 16b is equal to 56. So that b is equal to 65 minus 65 upon 56. So this is the value, calculated value of b from here, minus 56 upon 65. When we will substitute this value here in this equation number 2, we will obtain the value of a from equation number 2, that is a is equal to 7 times of minus 56 upon 65 upon 4. So a is equal to minus 98 upon 65. Now we can substitute these two values in equation number 1, that is yp is equal to minus 98 upon 65 cos 2x minus 56 upon 65 sin 2x. So that general solution of this differential equation can be written as y is equal to c1 c1 exponential 3x plus c2 exponential minus x minus 98 upon 65 cos 2x minus 56 upon 65 sin 2x. So this is the solution of this differential equation by using method of undetermined coefficient. Because in this method we have different kind of assumptions. When we have exponential function, we assume a, a exponential terms, a times of exponential term. When we have trigonometric function, we substitute a time of sine plus cos. And now this is third case in method of undetermined coefficient is polynomial case. So here in this problem we have a polynomial, that is y double prime minus 6y prime plus 8y is equal to 8x square plus 5. So our polynomial is x square plus 5. The complementary function for this will be from the auxiliary equation m square minus 6m plus 8 is equal to 0. So the values of m are 2 and 4. So the complementary function becomes yc is equal to c1 exponential 2x, c2 exponential 4x. Now, because we have second order polynomial, so we must be consider y is equal to a second order polynomial, that is y is equal to ax square plus bx plus c. So y prime becomes 2ax plus b, derivative of this polynomial, and y double prime only will be 2a. Now we will substitute the value of y prime, y double prime in equation number 1. So equation number 1 will be now 8ax square plus bx plus c from where I am writing 8 because this is the value of y, 8y, which is given into the question. So 8, 8y, look at this. The first term which is in the question is 8y. So 8y minus y prime, 6y prime, in the end y double prime. So that I am writing in such a manner that 8, 8 value of y minus 6 value of y prime plus y double prime is equal to 8 x square plus 5. Now multiply by 8 to the entire term, that is 8 x square plus 8 bx plus 8c minus 12 12 ax minus 6b plus 2a is equal to x square plus 8. Now equating, we have to arrange all the terms with in term of x, so that first we will write the higher power of x term, that is 8ax square, then coefficient of x, that is 8b minus 12ax plus rest of all terms 8c minus 6b plus 2a is equal to 8x square plus 15. Now equating the coefficient from both sides, equating the coefficient of x square, x and x raised to the power 0, this means constant. So at the left hand side, coefficient of x square is 8a, at right hand side is 8. So that 8a is equal to 8, so that a is equal to 1. And coefficient of x will be 8b minus 12a, that is, there is no x, therefore this will be equal to 0. So 8b minus 12a is equal to 0, a is 1, so 8b minus 12 is equal to 0, so b is equal to 12 upon 8, that is 3 upon 2. Similarly, coefficient of x naught, that is constant are 8c, 6b and 2a, and here we have 5. So 8c minus 6b plus 2a is equal to 5. Now substituting the a and b in this equation, so that 8c minus 6 value of b plus 2a is equal to 5, so that from here we obtain the value of c, that is 12 upon 8, it is 3 upon 2. So the complementary function, particular function from uh, the values of a, b and c would be yp is equal to ax square plus bx plus c, that is 1x square plus bx plus c. So x square plus 3 upon 2x plus 3 upon 2. Now the general solution of the differential equation will be y is equal to c1 exponential 2x, c2 exponential 4x plus x square plus 3x upon 2 plus 3 upon 2. So this is our answer. So we have discussed all the cases about the method of undetermined coefficient, exponential function, trigonometric function, and polynomial. If you face any problem to determine the solution of the any kind of differential equation by using any method of undetermined coefficient, method of variation of parameter, or also Cauchy's equation, Legendre equation, and other methods which we have discussed in our previous lecture. If you have any kind of problem to solve the differential equation of any kind, so you can write in the comments. I will definitely help you how you can pursue the solution of different kind of differential equation when you have some difficult types of differential equation. Thank you for your like, subscribe, and consideration. I always appreciate your comments, and especially your comments help me to improve my teaching skills. Thank you, my friends and my viewers, my students. I always be thankful to you. Assalamu alaikum.